Hi guys, welcome to today's recording. I'm just going to go through the organic topic very quickly. I'm not going to go into too much detail, but just to cover the important concepts and sort of what sort of grades that you'll be getting for each of those for these concepts. Okay, now I'm not going to go into, like I said, into the details of the flow chart or naming, for example. I will probably make something especially to do with the reaction flow chart later this year before the exams, but this is more just an overall summary of this topic. Okay, so let's get into it. I don't want this video to be too long. Let's get it out of the way. So the first thing that we're going to do, just with your naming and drawing. So this is just knowing your functional groups and knowing the rules for the IUPAC naming, naming the branches, taking priorities of the functional groups. Because if you can't name stuff, I mean, you can't really do organics. If you don't even know what they're called or what functional group it is, then you really have a lot to catch up. Okay, like say for example, if you see a CC double bond, you just know that this is an alkane, and then you will just know that it will do certain reactions. Okay, so for naming and drawing, this is normally kind of like achieved. Not depends on, if you do a topic test for your schools, maybe a teacher will be nice and give you a merit if you get all of them right, but realistically for NCEA examinations, it's only achieved. Okay, now once we've done that, we were looking at what we call isomers. So if you look at isomers, you were only looking at structural isomers, and then you're looking at geometric isomers. Okay, so with the structural isomers, so this means that you will get like say for example like C4H10, and then you can draw it like this, 4 carbons in a row like butane, or you can draw it like this, which is methylpropane. I'm not drawing the H's because again, just saving time here. Those are structural isomers because they all have the same number of carbons and hydrogens, but then they have different arrangement. Now for your geometric isomers, so at level 1, at level 2, this is more like kind of like achieved to merit-ish kind of question. For a geometric isomer, this is where your excellence is going to come in. Okay, so for the geometric isomers, you need to know that this is strictly in alkenes, in CC, they must have a double bond, because by having a double bond, then there's no free rotation around it. Okay, now the other criteria that you must have is that the two groups bonding to the two carbons must be different. Okay, so I'm just going to draw you the cis and trans isomers. So this is cis, this is trans. So if you look at the rule, it means that the two groups bonding to the carbon must be different. So I'm just highlighting them differently. So the two groups bonding to the carbons must be different, and then if they are on the same side, then it's cis. If they are on the opposite side, then it's a trans. Okay, so this is kind of like an excellence kind of question. And then you can have like an achieved to merit-ish type of question, which is like the degree of alcohol, like just identifying degree of alcohol and haloalkane, for example. So this is where you need to be able to look at, if I give you something like this or something like this. Again, I'm not doing the H's because the H's are just there. Don't do what I do, by the way. In the exam, if you don't write the H's, is wrong. But I'm just showing you that this OH is bonding to a carbon which is directly bonding to another carbon. This is a primary alcohol. This OH is bonding to a carbon which is bonding to 2 other carbons directly. So this is a secondary carbon alcohol, and this is a tertiary alcohol because the OH is bonding to a carbon which is bonding to 3 other carbons. So that's tertiary. So same with the haloalkanes like chloro or bromo. You just look at how many carbons that's directly bonded to the carbon that's bonding to the Cl or the Br or the fluorine. Okay, so that's pretty much it. And then the rest is all reactions. Okay, so for the chemical reactions, the thing that I always tell people to remember is obviously the flow chart. Now I personally hate to get people to memorize, like say for example, from alkene to alkane. This is probably a good one. You need what sort of reagents? From alkene to alcohol, you need what sort of reagents? I don't like remembering like this, because if you I can give you from the many years I've been teaching, I can tell you that yes, you can memorize that, but if you don't know how to use it, it's hopeless. It's a tool that you have to actually need to understand to know how to use it. So I personally always go with this. All right, so if you start with but-1-ene, like something like this, like say again, I'm not going to do it here, I'll do it later down the track. Like, would you know how does this turn to an alkane? So if you add H2 and platinum or nickel 200 degrees, what does that make? If you react this with your H2O/H plus, what do you make? And then do you know which one's major and which one's minor? So these are the sort of things. And I personally always go with the but-1-ene. Like, you can do this as a practice. Just put but-1-ene in the center of a piece of paper and just ask yourself, right, how do I turn that into an alcohol? How do I turn that into a chloroalkane? How do I turn the alcohol into that chloroalkane? How do I turn that chloroalkane into the alcohol? How do I turn the primary alcohol into the carboxylic acid? And how do I turn the chloroalkane into amine? So this is more of a, I would really, I highly advise against just memorizing that, because I've seen so many examples where students feeling very confident and they go into the exam, they're like, I got this, I memorize a flowchart, I know alkene to alcohol, I will add this reagent, I know from haloalkane to amine, I need to add this reagent. But then we don't ask you questions like that. We give them to you in this particular format. We give them to you in a chart. We don't and then a lot of people don't even, if you can't identify the functional group, how are you going to do this? And then it's only that through practice with the flow charts, just like I said, draw but-1-ene, and then just go with that. See if you can do it on your own. And if you could, that means you know all your reactions. It's as simple as that. And the people in my class, if you're listening to this, if you're someone from my school, I've done this with my class like so many times, like 4 or 5 different flowcharts that I've just drawn over the years. And I told them, if you can do my flowcharts, you can do any flowcharts, because they are much harder. Okay, so the flowchart reaction is quite, it's so much to talk about, and I can't do that in like hopefully a 10 minutes video. But then you need to know your addition reaction, which is just your breaking the double bond. You need to know your substitution reaction, which is substituting. You need to know your oxidation reaction. You need to know your acids and base neutralization reaction. And then you need to know, this is where your carboxylic acid turn into salt. And then you need to know your elimination reaction. So addition reaction is breaking double bond. You're breaking this, and then elimination is making double bond. Substitution is just swapping functional group. Oxidation is just gaining oxygens, and neutralization, this is year 11. So this is just acid plus base give you salt, acid plus carbonate give you salt, water and carbon dioxide. That's only for one particular reaction. Okay, and then the other excellence point that you might get is the major and minor products. Okay, and they will go, how do you know which one's major? How do you know which one's minor? And the way I normally tell people is to please don't, for the love of God, don't write rich gets richer, poor gets poorer. That's not the law of chemistry. You're giving me a common saying of a generic economic rule. Poor people gets poorer, rich people gets richer, which is true most of the time. But that doesn't, we're just saying that to help you remember. That's not a rule of chemistry. That's a rule of economics or social sciences. So to understand major minor, you just need to know if you're doing addition reaction, and when you have 2 possible products of the major minor, you just say the carbon with the carbon in the double bond, because you're breaking the double bond, the carbon that has more H's will most likely gain another H, and that's your major. The other one's a minor. And then for your elimination reaction, when you're making a double bond, so that means you're eliminating particles away from your molecule to make the double bond, then it's a carbon that has less hydrogen will be more likely to lose another hydrogen. So this is where the implication of poorer gets poorer comes in. Okay, so that's something you can practice, and this is like the flowchart is excellent, the major minor products is excellent. And then the last thing they need to do is a distinguishing test. So this is applying the flowchart, and then you just need to remember a few, right? You just need to know bromine water is great for alkane versus alkenes. One goes to colorless straight away, one goes to colorless in a few minutes with UV light. You use any sort of carbonate to get rid of the carboxylic acid because they do the neutralization. They do the neutralization reaction. Okay, and then once you've done that, you can have your litmus paper if you want to distinguish the carboxylic acid or the amine, but this is not a chemical test. You can use the oxidant, like say Cr2O72- H plus, or you can use the MnO4 H plus to balance the to identify the primary alcohols because they will oxidize, and then your haloalkanes doesn't do anything, so you identify that through elimination. Okay, so that, and then sometimes it will specifically ask you to write the equations, and for questions like that I would strongly recommend you to go have a look at my other videos that I've done in the past year or so about the older school or the older examinations, because the thing with organics is you really need to practice. Okay, so it's a lot of rote learning required, but if you really have to understand it first before you memorize, because no question is the same, especially with the flowcharts, and that's one thing I love about organic, because it's like puzzle solving. Okay, so so this is just a really quick summary for you to prepare for any topic test like my class is doing this week, or if you haven't learned it, or if you're learning it, if you're doing a topic test or preparing for an examination or something like that. And I hope this has helped you. Okay, so I'll keep this short, and I'll go through the flowcharts in more detail in the future. But like I always, hope you guys found this helpful. Subscribe if you haven't, and leave a like, and help the channel grow. And I'll see you guys next time. Bye bye.